Hello, tikulandireni kuphunziro lathu la lero pamene tikupitiriza ndi coordinate geometry. Lero tipanga lesson 2 ndipo mu lesson 2 imeneyi tiunikirana the equation of a straight line ndipo mukhala ndine Cicero Juma. Kungoyankhulirapo pang'ono last week tinaunikirana njira imene tingathe kugwiritsa ntchito popeza distance between 2 points. Tinaonetsana. I know there is a formula for that, but I did not show you the formula. Rather, I told you how to use the given information on a Cartesian plane to come out with the distance between 2 points. So, lesson is more practical. Coordinate geometry is more practical. I will not encourage you to memorize my formulas. I will encourage you to understand mene njira imene tikutsatira kuti tipeze chimene tikufuna. The same will apply today. We are going to derive an equation of a straight line. But there are formulas to that. But in this lesson, I will not dwell on those formulas. I will not even mention them. Rather, I will just take you through simple steps on how you can come up with these equations. Titikhala limodzi pamene tikupitiriza lesson. Kuona yamabwereza zikuthandizana kuti muthe kupanga visualize chimene chikuchitika. Coordinate geometry, you don't have to memorize. Chifukwa kutetsani pang'ono tifunso, you'll be confused. Rather, you just have to understand, visualize zimene zikuchitika. Let's have introduction. The equation of a straight line basically is a relationship between two variables. Last week, tunaonetsana this plane yx. Okay, so we are saying straight line is just a relationship between two variables. So when we talk of variables, we are talking of numbers that are found on the x-axis and numbers that are found on y-axis. So these numbers, if you get a number on the x-axis and a number on y-axis, you have a point, number on y and a number on x, you have a point, and the number on like that, number on x, like that. So that's some sort of a relationship you can have with that structure. So this line is only describing the relationship that is there between this y and that x. So muchichewa titaona kuti ndi ubale umene ulipo, imaonetsa ubale, that line imaonetsa ubale umene ulipo pakati pa y komanso x. Okay. In general, the general equation yopangira zimenezi amanali ndi y is equal to mx plus c, whereas y ndi imene mukuionayi, x ndi amene mukumuonayi. Pomwe m is a slope. Okay, in other words, it's called gradient. Slope kuti kodi chikukwera bwanji, titawerekeza kuti apa pali angle. Okay, so let's say that's theta. Ndiye ikulu bwanji, chikukwera bwanji. So that one is described by m, gradient. Okay, zikumasiyana botani. How is that relationship? So gradient shows that. Then c remains as x is the y-intercept. So pamene line yanu ikadule line ya y, in this case pamene, it's what we call y-intercept. It's a c. Okay, it's y-intercept. Okay, we need to understand that. So this is a general form of a straight line. Okay, that's a general form of a straight line. Y is equal to mx plus c. So that relationship for that one and that one is described by that gradient, which is m, or that slope, and that y-intercept. Okay, so that will determine the relationship yanthabirameneyo. So the whole idea, when you have a scenario like that one, you just have to make y subject of the formula. You can have different form of this, but you just have to make sure y should be dependent on x. Okay, so for you to have y, you need to have x. Something like that. Y depend on x. Yeah. So for the meantime, we are saying the general form of y is equal to mx plus c. That's the general form of a straight line equation. Okay, so the issue is, how do we find m and how do we find c? So in this scenario, let us consider this graph paper here. We have that y-axis, that x-axis. Okay, so that's y, this is x. Maybe we can say that's 0, this is 1, 2, 3, 4, 5, 6, 7, something like that. 1, 2, yeah, something like that. Okay, so on this one, we can have a straight line. Let's draw any straight line. You can have a straight line. So yeah. There's 8, 9, maybe there are 8. Okay. Yeah, so we may have that straight line. If you look at this straight line, we can, let's say, choose any 2 points. Let's say that's point A, and maybe that's point B. Okay. Now they are saying the slope of a line. Slope of a line is how, is the change of how the line is changing. Okay, it's how the line is changing in accordance with y and in accordance with x. How is it changing? Okay, so let's consider those 2 points. We can join these ones, something like that. We can have something like that. Okay, sorry. We can have something like that. Okay, so you will see that this point, let's have the what is this point? This is x, y, and y is 2. Here this point is 7, comma, in this case 8. Okay, that's that. That's the first part. We can consider this as theta. Okay, we can consider that as theta. But we know that, okay, let's take this out first. We know that tan theta is equal to opposite over adjacent. What is our opposite? This will be our opposite. Sorry. This will be our opposite because angle in this side, that will be our opposite. And that opposite is from that point to that point. Okay? So it will be there up to there. And now I think let's not use the numbers. In this case, this one is the same as to say x. Let us say this is x1. I mean this is x2. For here we have x1, comma, sorry, y1, x2, comma, y2, something like that. Okay. Remember that is it. Y is that one, which is 2, and this is x, which is that one. So that is the first x, so we are saying x1, and that is the first y, we are saying y1. Okay, the same applies that. So this one will be equal to opposite. Now opposite, this one will be y1 because it's here, it's 2, and y1 we know that it's 2. Okay, then there it's y2. Okay, and x on the x-axis it's there, so here is x1 and there is x2, something like that. Okay, so that's our opposite, y2 minus y1. Okay, because we want to find that distance, that distance between those things. Okay, we want to find distance between. So for us to find that, we need to do y2 minus y1, which is divided by x2 x1. Okay, so here you will see that the change in y divided by the change in x gives us tan theta. But we know that change in y divided by change in x is gradient. So we can as well say that our gradient m is equal to tan theta is equal to change in y, which is y2 divided by y1 divided by change in x. So that's our gradient. That's how you find the gradient. Now when you find that gradient, you substitute it there. Then let's see how do we find C. And remember we say C is y-intercept. When we say C is y-intercept, we mean like this. It will cut there. Maybe talk. So how do you find y-intercept? You find y-intercept, okay, by, okay, it's simple. You will see that our line is cutting y here. There, where it's cutting y, x is equal to 0. Okay, you can say at y-intercept x is equal to 0. Okay, it's there. X is here. X value is here. X is 0. Therefore, you can say that y will be equal to m times 0 plus c, which means your c will be equal to y, the value of y there. Okay. So in this case, it will be 1. So it will mean that you have found m, you have found c. You can just substitute in those ones and have your line equation of a straight line. Let's continue. Okay, let's have this example 1. They're saying write the equation 3y minus 5x plus 9y is equal to 0 in a slope-intercept form. Remember, we are saying the general formula of a straight line equation is y is equal to mx plus c. So we need to write this thing in that form. Okay, how do we do that? Here we are saying that y has to be subject of the formula. Okay, so how do we do that? So you will say that 3y minus 5x plus 9 should be equal to 0. Therefore, to make subject of the formula, that one, all those should go on that other side. You have, we are going to work out positive 5x minus 9. Then you divide both sides by 3. So that will give you, there we go, you have y equal to 5 over 3x minus 9 over 3, which is equal to 5 over 3x minus 3. So in this form, it will be 5 over 3x minus 3. So we may say from here, from this our equation that we have made it in that form, we know that m in this case will be equal to 5 over 3. And where the line is cutting c, it's cutting it at minus 3, at negative 3. Okay, so that's the gradient, that's the y-intercept. So let's continue. Let us look at an example 2. In this example, they're saying find the equation of a straight line that passes through the points 1, 3 and a point minus 2, 4. Write the equation in standard form. So we need to present this information on this paper, on this graph paper given. We have that y-axis. This is our x-axis. So we can say this is 1, 2, 3 going there. That's 1, that minus 2, that's 3. 1, 2, 3. I hope plotting a graph is not a problem. Minus 1, minus 2, and down. Okay, so 1, 3, that's 1, x, 3 is there, so let's put that point there. And minus 2, 4, minus 2, it's here. It's on the x side. And okay, let me point it. Minus 2 is here, and the 4 is there. Okay, so minus 2, we put that point there. Okay, so let's draw a straight line. You use a ruler. For me, I don't have a ruler. It will look like more of a sketch. Yeah, so remember our general form of equation of a straight line is y is equal to mx plus c. and we indicated that M stands for gradient and C stands for y-intercept. That's C, and how this thing is dropping, that's our gradient. Okay, so remember this point we are saying is negative, not negative, sorry, it's 1, 3, and this point here is minus 2, 4. Okay, so if we are to draw that imaginary triangle, we know this is theta, so we know that tan theta is equal to opposite over adjacent. What is our opposite? Change in y, change in y, change in y, change in y. Opposite is change in y. So our opposite will be, in this case, our change in y will be, in this case, 3 minus, and in this case, it's like we are moving from there, going down, moving from there, going down. So that's our thing. So we'll start with 3 minus 4. Okay, and on that side, divided by changing x, so it will be that's the starting point already. So it's 1 minus, in bracket, negative 2. Okay, so that will give you negative 1, 3 minus 4. So this one minus minus gives plus, 1 plus 2, that's 3, which means minus 1 over 3, that's our tan theta. And remember that our tan theta is our gradient, that is M. Okay, so we can as well say this is equal to our M. Okay, so now we know M, we need to find the value of C. For us to find the value of C, we just have to choose one point. It can be any. Okay, it can be any. It can be this one or that one. Okay, so if we choose any point, okay, let's use point 1, 3. Okay, so our y, we're saying our y is equal to minus 1 over 3x plus c. Okay, so if we are to put up those values, we know that is y. So where there is y, we put 3. And we know that is 1. Where there is x, we put 1 plus c. Okay, then we make subject of the formula c, it will be equal to 3. We are capital Q, it will be plus 1 over 3. This will be equal to 3 to 3, that's 9. And remember, that's 3 over 1. 1 into 3, that's 3. 3 times 3, that's 9. Plus 3 into 3, that's 1. Plus 1, that times 1, which is equal to 10 over 3. Which means our y-intercept is 10 over 3, which is equal to 3 point, should be 3, mabito. So it's there. That's our y-intercept, 3.3 going down. Okay, repeat it all. So our equation can be written as y will be equal to m. We found m as minus 1 over 3x plus 3.33, or we can as well leave it as plus 10 over 3. Okay, so that's our straight line equation. I hope we are together. For us to write it in a standard form, it's simple. It's simple. You just take x to that side, then you remove the denominators. Okay, by multiplying on both sides with 3. But that's not important. I think reaching that far, that's okay. Let's look at an example 3 now. In this example, they're saying we have a straight line which has got an angle theta with x-axis. Okay, the line cuts the x-axis at 8. If tan theta is equal to 1/4, find the equation of a straight line in slope-intercept form. Slope-intercept form, it's y is equal to mx plus c. That's the form. Okay, so in this case, we are given that well, there are a number of issues we need to understand this. We are given tan, sorry. So we are given tan theta as 1/4. But remember, tan theta, we have already shown, is the same as to say as gradient. And in this case, they are saying x-axis, the line cuts x-axis at x is equal to 8. Okay, let's put up this line here, this Cartesian plane here. That's x, that's y. Okay, any line, okay, wherever it's cutting x, it's obvious y is 0. Okay, which means this point is, this case they're saying at 8, it cuts at 8, so it means it's x8, y 0. Okay, so in this case we are given gradient and a point, and that point that you are given point, you can say that given point should be equal to 8, 0. Okay, because they have given us a hint that this line is cutting x-axis at 8. Okay, and we are given that. Now the question is to find that one. Now we need to find that c now, because gradient we know, and we have one point which we can use to find c. In this case, we'll say we can substitute. Okay, so solving, we'll say that solving y is equal to mx plus c. So in this case, y is 0. Y is 0. It's equal to m, and m is half 1/2. What is our x? Our x is 8 plus c. Okay, so this one will be equal to 0. It's equal to 1 times 8, that's 8, divided by 2, that's 4, plus c. Okay, so it means that c will be equal to 4 will go to the other side, will be minus 4. Okay, so our equation will be y is equal to, where there is m we put half x, in this case where there is c we put minus 4. Okay, something like that. So this one is our equation. In this case, sorry, I made a mistake here. I put 1/2. So let's just change there to be our gradient. Our gradient to be half. Okay. Yeah, so basically that's that. Let's use our gradient as half. Okay. Reaching that far, that's how you develop an equation of a straight line from that given information. In this case, you had the tangent and you have the point, 1 point. In the previous case, you had the 2 points without the tangent. Let's complete this lesson by looking at this example 4. They're saying find the equation of a straight line from the graph. So here we have a graph. Okay, consider the graph below. We need to find a straight line equation that's in that form. Okay, remember, by looking at that line, it's obvious that y-intercept is at 0. It's cutting y at 0, which means C, we know it's 0. Okay, now the remaining part is to find M. Okay, so for us to find M, we might choose that point, right, and that point. And this point, in this case, is 3, 3. Are we sure? Okay, 3, 3. And this point is 1, 1. Okay, so we may do the same. Or we may do this. Okay, that's theta. We know that for us to find gradient, we can say that tan theta is equal to opposite over adjacent. So in this case, what is our opposite, which is tan theta, will be equal to, our opposite is this one, which is 3, change in y, opposite is y, it's change in y. So it will be, here it's 3, minus, here it's 1, divided by change in x, so it's 3, minus, in this case, 1. So that will be equal to 2 over 2. So tan theta will be equal to 1. 2 over 2 is 1. So it means we have that y. This is our gradient. So we are just going to substitute. So that our equation y will be equal to y is equal to x. Because m is 1 plus 0, which means y is equal to x. What this means is that the relationship is the same. You move mofanana. So that's that. You will find that that gradient should be, I think, 45 degrees. That's how it's rising or falling. Okay, so reaching this far to see the I think let's meet again next lesson. Thank you.